Welcome to this explainer. Today, we are taking a literal trip through the cosmos. We're going to explore the phenomenal life cycle of stars, mapping out their grand design from that very first spark to their final, spectacular exits. But here's the twist. The source material argues that these magnificent cosmic laws actually reflect a much deeper, divine order. So stick around, because by the end of this, you might just look at the night sky in a completely different way. Let's kick this off by challenging a pretty common illusion. You know when you step outside on a clear night and look up? It's so incredibly easy to fall into the idea that the stars are just fixed, eternal little pinpricks of light. Like they've always been there and they always will be. But actually, scratch that. The reality is completely different and wonderfully dynamic. Stars are born, they live out their lives over millions or even billions of years, and they die in highly predictable stages. There is no random chaos up there. What we are really looking at is a perfectly timed, incredibly reliable cosmic clock. And according to the source material, this dynamic reality points to a divine mathematical precision. It uses this quote from Psalm 147, verse 4, to argue that these giant burning spheres of gas aren't just cosmic accidents. No, they follow perfectly designed laws. The text suggests that understanding how these stars evolve doesn't just teach us about space, it helps us understand our own place in the universe and reveals the incredible design behind creation itself. From this perspective, every single star has a purpose, a path, and an identity within this vast celestial order. Section 1. The stellar timeline, birth to dramatic exits. Let's get right into it. So, a star's journey typically happens in 6 major stages. First up, it starts out in a beautifully massive cloud of gas and dust called a nebula. Over time, gravity pulls all those particles together until they form what's known as a protostar. As gravity keeps squeezing, the core gets so unbelievably hot and dense that nuclear fusion literally ignites. That ignition kicks off the main sequence stage, which is honestly where stars spend the vast majority of their lives. But eventually, the star runs out of hydrogen fuel. When that happens, it expands outward into a massive red giant. Finally, depending on the star, it'll either collapse down into a tiny, glowing white dwarf, or it's going to meet a much more violent end, exploding into a supernova and leaving behind a black hole. Now, you might be wondering, what actually decides a star's ultimate fate? Well, the single most important factor is its mass right from the get-go. It's all about how heavy the star is. Small and medium stars take the quiet route. After their red giant phase, they just kind of gently shed their outer layers and shrink down into incredibly dense, hot little cores known as white dwarfs. But massive stars? Oh, they do not go quietly. They have an entirely different, incredibly dramatic destiny. Because of their immense mass, way more mass than our own sun, these massive stars burn through their fuel so much faster. They literally live fast and die young. When a massive star finally taps out its fuel, gravity wins the ultimate tug of war, causing the star to collapse in on itself so violently that it detonates in a massive supernova explosion. Guys, this explosion is so bright, it can outshine entire galaxies. What's left behind is either an ultra-dense neutron star, or, if the original star was truly gargantuan, the core collapses entirely to form a black hole. That's a region of space where gravity is so intense that absolutely nothing, not even light, can escape its grip. Moving right along to Section 2, reading the cosmic map, the HR diagram. Enter the Hertzsprung-Russell, or HR, diagram. You can think of the HR diagram as the ultimate cosmic treasure map. It takes all the stars we can see and plots them on a single graph based on 2 main things: their brightness, which astronomers call luminosity, and their surface temperature. By looking at exactly where a star lands on this map, scientists can literally tell at a single glance what stage of life that star is in. It's an absolute game changer. Let's break down how this map actually works. The vertical axis, the one going up and down, measures the brightness or the luminosity of the star. And the horizontal axis, the one going left to right, plots the surface temperature. So by cross-referencing how bright a star is with how hot its surface is, this perfectly ordered mathematical map reveals patterns that show us the life cycle of almost every star in the universe. It's like watching a giant puzzle come together. The HR diagram gives us immediate, undeniable clues. For example, extreme opposites emerge super clearly on this map. If you spot a star on the diagram that is incredibly hot, but also very dim, you know right away you're looking at a white dwarf. It's hot because it's a glowing core, but dim because it's just so tiny. On the flip side, if you see a star that's relatively cool, but insanely bright, you've almost certainly found a red giant. It's cool because its energy is spread out over a massive area, but bright because, well, it's just physically gigantic.
This forces us to look away from the far edges of the universe and focus right back on the anchor of our very own solar system, our sun. We often hear our sun called a main sequence star, but why exactly is that? What does that actually mean for us sitting here on Earth?
The answer is right here in its timeline. Our sun falls neatly right into the middle of that HR diagram on what's called the main sequence curve. It sits there right now because it's currently a medium-sized star that is perfectly balanced, steadily and consistently burning hydrogen fuel. It is in the prime of its life. But we also know its future. Billions of years from now, when that hydrogen fuel finally runs out, our sun will inevitably expand into a massive red giant, swallowing up the inner planets. And then, in the distant future, it's going to shed its outer layers and shrink down to spend the rest of eternity as a hot, dim white dwarf.
Section 3. Order, Wisdom, and Morality.
Here is where the source material gets really interesting. The HeroesmartAcademy Godly Learner series draws a deep connection here, arguing that this predictable cosmic order heavily mirrors how we should structure our own lives. There's an overarching philosophy that intertwines biblical morality with education. The series posits that education without a moral framework inevitably leads to choices that hurt. Just absorbing academic knowledge about stars or math or history, it simply isn't enough if you lack the moral framework to guide how you actually use that knowledge. The source material poses a really provocative question. What is the actual point? Intellectual knowledge of the stars, or anything else for that matter, means very little if we lack the moral compass to navigate our own lives here on Earth. Just imagine having a head full of facts, but continually making choices that damage your relationships, your health, or your peace of mind. It's kind of like having a high-powered telescope but pointing it straight at the ground, you know? True education, according to this perspective, absolutely must involve shaping our character, not just filling our brains.
And that brings us to the curriculum's final takeaway. Citing Romans chapter 8, verses 6 through 7, the text argues that just as the stars follow a divine mathematical precision, aligning your education with a spiritual mindset is the path to true peace of mind. You aren't just learning to be smart, you are learning to be wise. It's an interesting parallel to ponder the next time you look up at the night sky. If the universe maintains its brilliant, peaceful order by following its design laws, are you doing the same with your life?